What's up, everybody? I'm Sam Deiter.
Wes Bunn, how you guys doing today?
And today we're going to show you some of our VR carnival games that we've been working on. So Wes has been doing all the prototyping in VR, and I've been working on some of the art and pipeline things that you should consider before you start developing a project, especially with something that's as performance intensive as VR. I'm going to go over a little bit of what I did for the art, showing you how to make some mood boards, and Wes is going to start off with some of the prototyping stuff that we've done.
Yeah, we're going to walk through some of the samples here together again. If you tuned into the previous stream, Sam and I detailed that we want to make this as a full-fledged sample where we have a bunch of different types of interactions using VR and motion controllers. So that is the goal. So what you're about to see, again, is very work in progress. I'm sure as most of you are developing your projects, you prototype things out and it's all rough and dirty. So that's what you're going to see today, is the rough and dirty. So I guess we can go ahead and just jump in and kind of see.
Let's jump in, and you want to show them either in VR first?
Yeah, let's actually do that. I'm going to jump into VR here. I'm going to go ahead and start us up, Sam.
Go ahead and get you started. So, this one. Now we have a bit of a problem. We might lose one of the controllers. Slinging it around makes the batteries kind of wiggle, so we lose connectivity every once in a while. So please bear with us if that happens.
So in the previous stream, Sam and I kind of showed this game here, the can toss, the simple carnival can toss game. So we can go over and pick up a ball, and we can throw it at the cans, and try to knock them off.
It's way harder than it looks. You're like, oh, why can't I hit the cans off? This should be totally easy, and it's actually quite hard to do.
I think I lost that one. There we go. So this is what we had last time. We showed this last time, kind of walked through setting this up. Look at that, I almost did it. So big fat I lose on the scoreboard up there in a second. So we showed that, and in the time since the previous stream, Sam and I, again, this isn't a full-time project that we're working on, so whenever we have spare time, we try to work on this.
On this Friday, or for our Epic Friday, we'll be hitting this project back up.
Yeah, so whenever we have a spare moment, we try to work on this. So I wanted to try and prototype some other sample carnival games.
Now, one of the cool things that Wes and I have been talking about doing is making this very modular as we possibly can, and that's one of the things he did with the blueprint for this game. Is a lot of the components, it shares a similar blueprint interface, but each game can be different.
Right, so we'll walk through that here in a moment when we jump into the editor. As Sam mentioned, it's very modular, so this booth...
You might have to stand up, dude.
I'm all right.
Okay.
This booth is actually a blueprint, so I can kind of modify it. I can have it, like on the next booth, that one's open. I can modify it right inside the details panel and just make it open if I want.
Okay.
Make some different adjustments to it. The scoreboard is also its own blueprint that I can modify in each individual game as well. So look at this left one here. I don't know why it's doing that. So I can go ahead and try and pick up the ball
there we
here
go.
For this one. And as soon as I pick up the ball, the timer starts, and let's try to shoot it up into the basket. And it's just a static mesh that I'm using up there. Sam is working on some of the art stuff, so we'll get a better looking hoop in a little bit. But the intent was to make some quick and easy carnival games using motion controllers.
Yeah, I mean, art isn't going to make it any more fun to play. It's just going to make it better to look at. So, you know, if it's fun like this, which Wes and I have been playing around with it, and it's actually quite challenging. You already lost, bro.
Yeah, I know.
You lost, bro.
Twice.
Oh, look, and then you won. You lost and then you won. Oh.
That's hacks, development hacks right there. So this is traditionally a game that you see at most carnivals, the little shootout thing there. So we made that one. And then literally yesterday at 3:30, I started working on this one.
3:30 to like 5.
Right.
We got the skee ball. It's very work in progress. It's a little rough, but it is skee ball.
So I can actually
move out of the way without getting smashed.
I always do this. I always pick my headset up to make sure I'm not going to hit anything, and I do some practice runs to make sure I'm not going to slam into something here. Terrible.
I've smashed Wes so many times with the motion controllers.
So it's all just blueprint, simple blueprint stuff. We'll walk through some of these here together. I wanted to try and build this one on screen, but we were having some issues with the setup. So we'll walk through this one here since it's already in place. But again, this one has a timer. The timer says -150 right now because it's starting on event begin play instead of actually picking up a ball and starting the timer, which I haven't gotten to yet. But you can kind of see how it works there. That one should have made it in, but each of those meshes up there, you know what I realized the 11th hour yesterday? That there was no hole in the middle of it. So although the collision is, there's a hole appearing in it, the collision is all the way around it.
Yeah,
so it doesn't actually go through.
It's not a tube, it is a cylinder. So.
Right. So, and then finally we have this one that's like a break-up plate. So traditionally you throw a ball at it, but we saw some comments on how to pick up like weapons and stuff like that. So far we've been picking up balls, and now we're actually going to pick up a weapon. And the way that we set this up, the logic is so that you can create any kind of actor or blueprint and be able to pick up any item that you want just by deriving it from a master blueprint class, which holds all the logic for picking up items. So we'll show that as well in a moment. So I have my gun here, and I can go over and kind of pick it up like so, and then aim and try to break the plates here. I can move over. One's moving a little bit faster than the other. Broke 2 for 1 there. Look at that. Kind of plan that one better.
So the other thing that we are thinking about doing is having a bow and arrow. But that is...
I wanted to talk about this for a minute too, actually. So there's a couple things here. So when I pick this up, there's one thing that's going to happen. So I have my left motion controller here. As I move over this, I'm sure if some of you have experimented with attaching things to actors and so forth. If you are new to attachments, I kind of wanted to point this out. So as I move my motion controller over it and I go to grab it, you see it kind of pops into place there. What we're doing there is snapping to a target point. So this arrow right here, this little red arrow, it's snapping directly to that. It's just a setting that you can make on the blueprint now.
Is it like snapping to a socket or something
kind
similar?
of. Well, I've
oh, you're literally snapping it to that
yeah,
red
I
arrow.
told where I wanted it to attach to through Blueprint script.
Okay.
But there's some options that you can set on that node. So you can have it so that it actually snaps to you, or you can have it where it keeps its world space, like this arrow. So now if I pick up this arrow will actually just pick it up wherever I pick it up from, instead of snapping to. I kind of wanted to show that. I mean, it's nothing really new for blueprints, but if you are new to blueprints and attaching things, that's something that it can be set on the node itself. But back to this bow and arrow, this is something that I wanted to show for this, but there's some things that you need to consider, specifically when working with VR. For a non-VR game, this would be pretty simple, actually, and I already had it working for a non-VR. So if you pick up this bow here, first of all, being able to determine when you line up your arrow here, what happens if you twist your hand and pull back like this? Does the arrow shoot off in that direction? What happens if you turn your hand around and do it? So there's all kinds of things you got to think about.
In the face.
Yeah. So if you were making this for a non-VR game, what you would probably do is, reach back, grab the arrow, and go into this motion here, and you would be locked in this motion. And then when you pull back, it would move linearly back. You wouldn't have this movement here. So it's all kinds of things like that you'd have to consider to set up when setting this up for VR, which I have limited VR experience, especially with motion controllers. So I want to dig more into this. And one of the guys on our team here actually has a prototype of this working.
Ryan Brooks, the crazy Unreal wizard.
Yeah, so I'm hoping to meet with him before our next stream so I can kind of see how he did it.
He made an amazing bow and arrow that works just like a real bow and arrow. I saw the bow and arrow in the back of his house. I was like, "What you shooting archery now?" He's like, "Oh no, I was testing to see how accurate my bow and arrow that I made in VR was versus real life." I'm like, "Ryan, you are a crazy man." Yeah,
when I was playing with it, I was using a blend space for the cord. So as you pull back, the cord kind of bends and comes back with you.
That's cool.
So it worked, and I could actually, based on the distance from this hand to this hand, actually, alter the projectile movement speed.
So many other
the variables here, I was like,
math and just there's so much stuff.
Some of the vector math I could use a little bit of help on. So we'll hope to have that in the next stream. Maybe we can. Even if Ryan has time, maybe he can come on with us and explain some of it too.
Maybe we can get Ryan on the stream with us next time to go over some of the bow mechanics, because he spent a lot of time working and figuring all that stuff out. So
yeah, that would definitely.
We'll get him on here because he's definitely a subject matter expert.
That would definitely be a class for me as well. So we're actually going to take a look at the project that Sam and I have been working on now. Pop that up. We're just going to walk through some of the blueprints here really quick on some of the settings. And then we'll try to jump into some of the material stuff and static mesh and art side of things.
We can go. There's a couple things that I wrote down. I made some speaking notes. I forgot my laptop, so I got to use my cell phone here. But I want to talk about some of the stuff like coming up with an art style, how you figure out the style that you want to use, and then things you need to consider, how your team consideration, how big your team is going to be. Are you going to use source control? What are you going to do for source control? And then art pipeline considerations. What software are you going to use? Yeah. How do you determine your triangle count? How do you determine how many materials you want to have? And a lot of this stuff is, in other projects, you can kind of I can go in with a loose idea, but because VR is so resource intensive, you really need to kind of plan this stuff out
beforehand
because it has to run. And this is this is kind of the good and the bad. You know for a fact you got to hit 90 FPS or 75 FPS or whatever the FPS is for your headset. So you know what your target FPS has to be right out of the gate. And you can't, unfortunately, in a regular video game, if you're targeting 60 and it drops down to 50, 40, not that big of a problem. In VR, that's a VR experience killer. So I think the best thing for us to do is, do a little bit of homework, like Wes said, and think about these things so that when these problems do come up, at least you have a plan of attack, or at least you've thought about it, or you're familiar, not blindsided by this stuff. So we'll go over that as well.
Okay. So we're going to take a look at the project here real quick. Just going to walk through some of the setups here and talk about some of the decisions that were made. So we have the project up. Let's see, is it up on screen?
Can we kick over to the project?
Thank you. So we walked through this one last time. This is the can.
I don't know why the cans are black, but
I don't either, actually,
we'll fix that later.
So this is the can toss. It's its own blueprint here. So if I click on this is the actual can toss blueprint. It holds all the logic for winning and losing. There's some settings that we can modify right here in the details panel, so we can specify how many cans are remaining.
Maybe show them the taking the thing off of the blueprint and do this, opening up the front.
Oh yeah, I'll show that in a moment. So for the can blueprint here, you can see you can modify the name. The text that appears on the HUD up here. And this HUD is actually its own individual blueprint. We're just targeting an instance of it. So I browse to it there. It's right here. This is the one that we are talking to. So that way we can just reuse that asset for any of the games and then just target individual instances of it and then populate the text as we need. So before we were thinking of incorporating the HUD into this particular blueprint. So having the HUD and the mechanics all in one blueprint, one master blueprint where we control everything.
Kind of like doing master material.
Yeah, doing it in a bunch of individual pieces. We can kind of pick and choose which parts of it we need through blueprint script.
Yeah, I think you were also saying we were having to do a lot of things with blueprint interfaces, and it was just going to become a little bit of spaghetti.
Yeah, it's much easier to do direct blueprint communications for this type of stuff because it's a one-to-one communication. I'm communicating from my master blueprint here that has the game logic directly to a HUD. I'm also communicating to the balls, which are their own blueprints. It's just easier to do it that way. So the actual HUD here, it's just a widget blueprint created through UMG. I created some additional lines here. So we have the first line, second line. These are all optional. You can use which ones you want. So for this game, we're only using like cans remaining and the balls remaining. We're not using third line, so we hit it. But in the other games, you may want to use that. So I added additional lines so that you can toggle them on and off.
Okay,
so it makes it just a little bit easier.
Eventually going to need them, but it's kind of, you do it now so you don't have to do it later on.
Yeah. I was going to talk to you about this. So this is our...
the collision looks insane.
Yeah, right? This is just the basketball shootout here. Now, traditionally in those basketball shootout games, you have like a net or something that kind of corral the balls back to you. So I just, for prototyping purposes, we just have some collision boxes angled to make them come back to you. So that's kind of how that was set up. And again, this particular blueprint is right here. We just made a marker so we can see it. Again, this one has some info in the details panel that we can modify. These are all publicly exposed variables, so you can come in and tune and tweak them right here inside the details panel instead of opening up the blueprint. With this blueprint selected, again, this is the logic for the shootout. You can see this little box here. This is the starting area. When the player pulls the ball out of this, that would actually trigger the time. So that way you know when to start the time, etc. I just haven't done that for the skee ball setup. Back to these little booths here. I just made a Boolean. It's really simple, actually. Oh, okay. I just made a Boolean and then construction script. You can toggle it on and off right here.
That's awesome.
So that actually, if you just open that up,
I know it's so simple, but it's really cool because normally, like, to get that type of interaction going on, I
sometimes forget. Like sometimes when I create some of these things, because I've been working for Blueprints for about a year now, even the little things like that are like, oh wow, I didn't know you could do that, to somebody that's completely new to Blueprints. So it's good that we point that out. So that's just done right here inside the construction script. So whenever that blueprint is moved,
so basically all you're doing is toggling the visibility and the collision. So basically you're saying when I turn on the collision. When I turn it off, turn off the collision.
Yeah.
And that's, I mean, that would have been a couple lines of code, but with the blueprint script, it's just super easy.
Yeah. So the skee ball one, again, this is something that was just a work in progress here as well. We just added some collision boxes. It's very similar to
Basketball?
Yeah, the basketball and the
Can
can
toss.
game. So if I go down to the actual blueprints folder here, go into these game types. So here's the can toss. All I did was just right click and duplicate this and then open that blueprint up. And all the logic for the can toss is here. I just made some modifications to it. If I go to the viewport here, we have one scoring area. So when a can falls off the table and lands in this area, it triggers a score. For the basketball game, we had one scoring area, but for the skee ball, we had multiple. So I just added additional volumes to check. We actually open that up. Let's open that up. So if we go to the viewport here. So it's just a bunch of different volumes and the ball inches that we're doing. So and then you can add on begin overlap events for these. It's really simple stuff. So when the ball overlaps, assign 20 points, and then go through the process of actually updating the score, which is up here. So add the current score that you just scored to the overall score, etc. And update the scoreboard. Pretty simple stuff. That's for our timer. This is for when the ball actually lands in one of the scoring areas. We turn off its collision, we update the score, we make sure that the ball is valid, and then we destroy it and we spawn a new one. So pretty simple stuff there. I did want to show the pickups because this is one of the things I think came from the last stream, actually how to pick up different objects.
Okay.
So what we did for that, if we go to the blueprints and the items, what we did for that, if I go and find, let's see, where is it? Pickup item. So this is our parent class, our pickup item here. We added a skeletal mesh, and we also added a static mesh, and they're both null. And whenever we want to pick up a static mesh, we create a child from this blueprint and populate the static mesh with whatever object we want. And if we want to use a skeletal mesh, then we populate the skeletal mesh. There's actually no script in here. It's just a container, so that whenever we go to pick up something, we can say, is the item that we're trying to pick up a pickup item? Because the items that we create are children of this, it knows that it is of the pickup item class. So you don't have to have a gun pickup, different logic for different things. You can have one master thing, call that when you try to pick up something. And if it is a pickup item, then you can
you'll be able to pick it up.
Yeah.
It doesn't matter what type of, it could be a bow or an arrow.
Yeah, it can be whatever you want.
Okay.
So if we go to one of the other blueprints here, so we have, let's see, there's an arrow. So the arrow, all we did is, you can see it's inheriting from our parent class, the pickup item, and we just populated the static mesh with an arrow. Very simple to do it this way. We can add balls, we can add guns. Where's our gun? I don't know why the gun has a can on it. Oh, that was because it was a can, that's why. That's why it was a can. The gun here, so the gun has its own logic, and this way you can provide individual logic for individual pickup items. You don't have to have a master pickup. I think in the previous video
I could pick up the gun and the bow and arrow and have
different logic
or
for
let's
different.
say I pick up like a gun, a shotgun and a handgun, right? The shotgun would have like a wider spread, but it's all coming from the same parent class.
Right.
Okay.
Just to pick up the item, the individual logic for each individual pickup can be handled in the child.
Okay, that's awesome. That's awesome.
It just makes it a lot easier to do it that way. Before, what I think we were doing, we had a master pickup, but we were including all the static meshes and everything inside that blueprint, and then picking and choosing from there. Just inheriting from the parent class.
Yeah, this makes it a little easier to read.
Yeah.
Blueprints can get a little unwieldy sometimes when you have a billion things inside of them.
Yeah. So let's actually open up the character real quick. There was one thing that I wanted to show in here. So we kind of talked about this in the previous stream, the logic for picking up items. In case you missed it, again, there was a question on the forums. I think a guy was having a problem actually getting it to work. So I wanted to walk through that again here really quickly. All we did was set up our motion controllers inside the character blueprint, and then nested under those, we have a collision for actually picking up the item. So this little box here determines when we are in range to pick up items. We have a mesh to represent our hand. Currently, it's just a box.
Yeah, we were actually, just time is our biggest factor, taking some of the stuff from Bullet Train or the other free stuff that we just launched from Infinity Blade. Infinity Blade dungeon characters, and trying to take some of their hands, cut them off, and turn them into actual hands.
We'll get to that point eventually.
So it's on our list of things to do. You're not going to be a block person forever.
Yeah. Also in the previous video, we talked about a spawn location to attach things to. So if we had a an actual skeletal mesh, a hand with bones in it. We could attach things to a specific socket. Like we can specify a
like
bone.
put something on the palm or something like that.
Since we don't have that, we're just using an arrow as the point of reference of where to
Makes
attach
sense.
things. And then we had a particle. I disabled it for now, but we had remember we had the lightsaber things.
Oh yeah, the light to show
kind of show where you were aiming
at.
I just disabled those for now, but they're still there, and we can populate them.
Yeah,
later,
we could even maybe turn that into an option or something.
Yeah. So this is the basic setup for our motion controllers and being able to pick up things. The most important thing is the collision volume, making sure that it's set to overlap all dynamic and generate overlaps is checked. With those set up, whenever we overlap something, there's that pickup item that we were talking about. Did I overlap something? Yes, I did. Is it a pickup item that I overlapped? If it is, then go ahead and store that as a reference, and we can do it for left or right hands. And then we're also going to say that we are in range of picking up the item at that point.
Oh, that's a good question. Does the item have some type of collision volume?
The item itself has collision on it.
Okay.
So, yeah, you can pass.
So you've got to actually go through it, then you'll be picking. Okay.
Yeah, we could expand that. We could add a volume around it so that when you enter that range and then have collision on the particular item
object
itself,
it'll
we
pick
could
up.
do that. Just haven't gotten to that point yet. I figured I'd wait till we get the hands in there to
Yeah.
kind of see how that's going to work.
If that works better or worse.
Yeah, the other thing...
It's crazy how things you think they're going to work really well, and then you actually do them, you're like, yeah, this isn't so hot.
The other thing that we changed from the previous video, if you are coming from the previous video from our series here, we had the right trigger. So we had the right trigger picking up and throwing things. Remember that?
Oh, yeah, you had to release the trigger.
And then when we got to the gun, I was like, oh, how are we going to shoot?
Yes.
So we switched it over to the actual grips. An interesting thing about the grips, I think we mentioned this in a previous video, there's 2 buttons for grips.
Yeah, it's not just one big button. It's a left and a right.
Yeah, so I found in experimenting with this, you could actually just use the left grip, and it works just as well.
Okay.
If you're trying to grip something, try to grip that. Your natural motion is to squeeze both together.
Yeah, you squeeze it between here and this finger, but that right there, just squeezing with my finger right there is...
Right, so I'm only using the left grip to actually determine when you go to pick something up, not both.
Okay.
So we're just using the left grip here, so if we hop back, whenever the left grip is pressed.
I don't know if we talked about this on the last stream. We couldn't get the trackpad to work. Remember? Did we? I don't know if we talked about that or not. I think that's worth mentioning, though.
Oh, yeah, we did.
Oh, we did?
About recalibrating?
Yeah, recalibrating.
Yeah, we talked about that.
Because half of it wouldn't work. We were like, why doesn't this work? We had no idea.
So the trackpad on these things are touch sensitive. They're not
very sensitive.
You don't have to press on them. Yeah, very sensitive. If you are moving around the trackpad and you can't figure out why you're not moving, you may need to recalibrate it, and you can do that by holding down the trigger, and there's a little black button under the red button here.
Red one, yeah.
Hold both of those down and turn it on. You'll get a different beep to let you know that you are recalibrating it.
And literally, the thing will just start working.
Yeah. I could only move in one direction now.
Yeah,
I could only move in one direction.
Forward,
I couldn't move back for some reason.
And even if you turned around, you still couldn't move backwards. You'd
just
still
needed
go
to be
forward.
recalibrated. So back to our character here, the last thing that I wanted to show real quick, summarizing the actual pickup logic here. So we've determined that we are in range. We press the grip button, the left grip button here, which is grip 1. Are we in range? Make sure that we are. Then we're going to pick up the item. The item that we are picking up, we're going to attach it to whatever hand, so our right arrow or our left arrow. The item that we are going to attach is passed through when we overlap. So we go to overlap, gets a reference to what the item is, stores it as a reference. If I click to pick up that item, it knows what item it is, right? That gets passed through as the item to attach to your hand. And we also add a Boolean just to make sure that we have things in our hands so we can't double pick up things. Okay. So we're saying, item is held at that point. If we use that particle, we could turn it on at that point as well.
Okay.
The last thing that I want to mention here on the pickup item here, double click that, the script for that. Here's where we are determining what to attach. So we determined that we want to pick up the item. This is our hand. This is the pickup item reference, so that parent class. We're going to pass through and see, is it a static mesh? So is it a ball? Is it a skeletal mesh? Is it a gun or an arrow, for example? Based on that, then we're going to attach it in different ways. So this is the node that I want to talk about, actually, the attach to. Some of you may have used this before. Weren't quite sure what the attach type was. This is where you can snap it to a specific location, or you can keep the world position. So it's just literally just a drop down at that point. So if you have things that you want to just pick them up as you pick them up, or if you want something to snap to, you can use that drop down here. So that's attaching, and dropping is equally the same process here. Getting a reference to the item that we picked up, determining if it's a static mesh or a skeletal mesh. There's some extra stuff that I threw in here for the skee ball that I was testing. So once we determine that we are going to drop it, we're going to detach it from the parent. We're going to set simulate physics to on. I had it off by default, because what I noticed is you'd go to pick up a ball and your static mesh of your hand would move the ball and knock it away. It's like, yeah, let's just turn physics off for now. And then when you pick it up and then drop it, then
like
turn it
Mr.
on.
Magoo, you're trying to pick it up, but you keep kicking it out of the way.
That's my dog, actually. My dog does that. So anyway, yeah, some testing that I was doing with the skee ball. One of the things I noticed with the skee ball is when I threw it, no matter how much force I generated with my hand, I still wasn't getting the speed that I wanted. So I'm adding an impulse to the ball when I release it.
Okay.
Based on the velocity, just trying to kick it up a notch. This is one of the things that I want to talk to Ryan about, or some of the guys here, to kind of see how they handle this type of movement, generating velocity.
Generating velocity when you're
adjusting based off of that.
When you're moving your arm, or like throwing a grenade or something like that. Although throwing the grenade, I would be wary of.
Throwing a grenade.
People tend to throw things when they throw a grenade, and you don't want somebody throwing like a motion controller at your TV.
Right. You can, through Blueprint script, affect the velocity when the object is spawned. Since I'm not spawning it and it's already in my hand, I tried activating like a projectile movement, just turning that on and kind of launching it based off of that velocity. I don't know if that was the best way to do it. So this is one of the things I'm still kind of trying to figure out what's the best way to do things. These are the ways that I attempted to do them.
And they work.
And they work.
There might be a more performant way to do something.
And best practices. And that's what I want this project to have.
Yeah, these become more important when you're doing like, vector math, or like you're trying to change some transforms or something like that. And also stuff's a little over my head as well. So I would always need to talk to, one of the Nicks or Ryan or one of our mini genius programmers that we have here.
Yeah. So I think that was all I had for now. I don't know if there's any questions. Do we have any questions?
Yeah, I've been going back and forth. So this one, I'm not sure. It says, can they show how it looks like when they add more cans? I'm not sure. Like, can we dynamically adjust the can toss?
The number of cans, yeah.
Yeah.
So if we wanted to add, let's just take all of these. And
maybe just duplicate them back or something?
We'll shift these up.
Okay.
Take all of these. Hold Alt and drag those down. So do something like that. So we have 3 more cans that we added. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9. We can go to our little blueprint here. We can say cans remaining is actually 9 to start. And that's it. That's all we'd have to do.
That's it? Okay.
Yeah, so we don't have to actually go into the blueprint and make any changes, because the game logic is based off these variables here, and we can set those in the details panel. So it makes it very easy to tune and tweak this. We could have multiple stands. Some stands have 5, some stands have 1, 2, center 3. So
the other one,
very simple.
We only actually have 3 questions right now. The other one is, in regards to performance in VR, would it be best to use simple materials and not textures, or would that be more performance intensive? That's not really, I can't really say, because I would need to performance test that. Also, if you're doing, you're not using any textures, but you're using a lot of heavy math, to maybe like make some blotchy stuff or make it look like it's wood using procedural stuff. That's actually way more expensive than using a texture, because at each pixel you would have to recreate all of that stuff. But this is where, and once we get to that point, I will do one of the streams specifically over performance debugging, and how I told Wes, like, hey, this is way too expensive. We need to position this somewhere else so it can be occluded by something or something like that. It would be best, and I can actually, if we go over to one of the materials, I can actually show you how I kind of came up with, let's click on his instance there. And then, I'm going to steal the mouse really quick. So you see the can is really simple. It's just a base color, a normal, and then a roughness RGB pack that I did. But if I come to the parent, which is right here, now the parent hasn't changed. The only thing that happened was originally I had just a 3-channel vector, scalar for metallic, scalar for roughness, and then just a default normal map. Now, as I started to recreate things, as I started to make stuff and found out like, oh, I need a texture for my base color, I started adding switches. So this one's use base color texture, which you can see is a switch right up here, use base color texture. So as we started to introduce more and more complexity, I started to introduce more complexity to the material. Now, a lot of people out of the gate, they're going to build this huge parent material. My first job in Germany, we had a parent material that took up most of the material editor, but people only used one branch.
Fraction of it.
Yeah, they used a tiny little fraction of it. So this is my own personal flavor of this. I would rather build something small and add on to the top of it when it's needed instead of giving artists a whole bunch of choices because they're not going to know what all these choices do. So they're just going to pick what they know works.
Yeah.
And they see, oh, I see specular, I see normal, I see albedo. Done. Let me just plug these in. Oh, I see a multiplier for those. Yeah. Oh, I don't know what this crazy parallax offset does. I'm not going to do anything with it. And then that stuff doesn't get utilized. Yeah. So, save yourself some time and energy.
Yeah, your artist can always come to you and
they can always come to you and say, hey, you know what? I need some fancy parallax offset for this. And then you can put it in there with a switch. Everything in here has got a switch. So it's true or it's false. It will either enable or disable that branch of the shader. And this is just to keep things as simple as possible without making it too overly complex or really kind of hamstringing us in our development of this. And as we approach the end, we could also find out like, you know what? I found out that I never actually used base color. I'm just going to completely bypass this entire thing and just go with the straight up texture because I know that we never use that for this particular material. Or I might shuffle some things around. I might make a simpler version of this material that just has base color and roughness and use that for a few other materials throughout the game. So it's an iterative process. You don't have to get it right out of the gate, but you do need a performance test, and we will cover that in a little more detail once we get there. Is there any plan to add better IK with more joint constraints now that it's more important with all the upcoming VR? I have no idea. This is something Wes and I were actually talking about with the hands. Having it so like the hands will work like I reach down and I grab something, and that's how it is in Bullet Train. So it's seeing what the Nicks, what Nick did on there, or what Ryan did on there. To figure out how they got those hands to work in that manner, because they work really well, and we want something similar to that. So it's a learning process for us as well. So, all right, so that's it for all the questions that we have right now. I want to show you guys what I have been working on in the meantime with Wes. Boards. So let me go to my notes here so I make sure I don't forget anything. So. As we've been going along in this, we've been talking about games, and I've just been kind of making artwork. Just, okay, I know how this thing looks, and I've been, just kind of arbitrarily making artwork. This weekend while I was out, as most of my ideas come to me as I was walking my dog around, I realized that I needed to take a big step back with the artwork for everything, and I needed to provide Wes with some white box message, just so we can have some stuff to look at. But I needed to come up with a theme. What is our theme going to be? Do we want to do a realistic style carnival that's, hyper realistic like Bullet Train? Do we want to do something that's a little more cartoony? Do we want to do a kind of a mix of the two? Also, what do we want all of the games to look like? What kind of games do we want to have? So I went on a rampage, and so far to this point, I'm up to 265 reference images that I've gathered, and I put them in these little things called mood boards. And this is a mood board, and mood board is just simply, looks like I have a little artifact right there, but basically it is a collection of images that represent, this one right here represents the bag toss. So we can see, we've got some bean bags over here. We've got the clown down game. We've got another one which is more like a bushel basket toss, or you can toss it through the mouth, or you can knock the cans over. Just to give people an idea, give artists an idea.
It's a good talking point too, especially in working with a team, having something like this to come together and sit down and say, okay, what works, what direction do we want to go?
Yes. It's better than just saying, if I go back a folder, let me go back one. You can see I have these images here. So let's look at the bag toss. I'm sorry, that's the ring toss. Let's go back and where is it? Oh, because I called it milk can toss, I do believe. Milk bottle knockoff. There we go. It's a lot easier to give somebody this, right, than having them look through all of these individual images like this, because they're gonna go through. They're like, okay, whatever. Yeah, all right. Yeah. Giving them something like this that's kind of a more cohesive collection of images, they can see like, okay, I see they want to do something with the bean bags. Okay, we have a couple options.
To try.
It's just a better way, in my opinion, to bring the images together to kind of sell what your idea is. So I put a lot of these together. Here's the one for the basketball toss. This is actually kind of interesting. If you notice that it's squished right here, this image is actually from a racketeering trial based on this basketball game, believe it or not.
The one on the left down there, that one is awesome.
Yeah, this one. This is the main one that I used, right? I was looking at this. I made a basketball goal like this, and then I started doing my image search on them, and I'm like, wait a second, these things are all squished.
Realistic here.
Yeah, so... and if I hadn't put all these images together, I wouldn't have been able to see the differences between a regular basketball hoop, which I got right up here, and this basketball hoop. And this is still my favorite image out of all the images I found because it was from an affidavit about racketeering on this particular game that we're making. That was pretty funny. So we've got... this right here isn't a specific game, but it's just images from like carnival games. So when we go to make, maybe we do something different with the stalls, and we see that we've got stalls here that are
enclosed in the back.
Yeah, enclosed in the back, open on the front, and similar to what we're doing on the side. We can see something like here, like all of the animals that are up here with the lighting and just the coloration that you're getting in here. All of the very, very bright pastel style colors. Like, this is all stuff that you have to think about, but you don't necessarily think about it when you're making the artwork. Let's see, what else have we got here? We've got these are just some more images of just random carnival games, and literally all I did. This is a cool one. This is a Wii game that I found that does a lot of the carnival games, and I really like this particular style. I forgot what the name of it. It was like Wii Carnival or something like that.
Yeah, see the one in the upper right there with the dual basketballs?
Yeah.
It's like it's multiplayer. That was one of the things that we talked about.
Yeah, we had talked about doing something multiplayer.
Skee-ball too.
So, but I really like this cartoony style, and I feel that it lends itself very well to VR. Obviously, we've seen Bullet Train, which is hyper-realistic. That totally works. Hyper-realism is just getting everything in there, and it's a lot of work to get all of that stuff in there. I believe a cartoony game with a team of just 2 people is a little bit easier. Yeah. It's also a little more forgiving if there's any type of problems, and a regular experience or something that's approaching realism, the instant something doesn't happen the way it is in reality, your brain automatically rejects it because it's like, this is supposed to be reality and this isn't working like reality, so there's something wrong here. So when you introduce that cartoon element to it, your brain is already like, well, I understand that this is not really real, so I can be a little more forgiving. So these are things you need to think about before you decide to pick a particular art style. We were thinking about doing maybe a dart toss game or something like that, so we got some images together.
A lot of the mechanics that we're setting up can be applied to some of these other games, which is why we set it up compartmentally like that.
Yeah, so we can just do very modular. We've got the frog flinger, where you just hit the frog down and he goes flying into the air. Lawn darts. I always liked this game because it's really dangerous. Milk bottle toss. These are kind of cool. So my buddy Anton Magunoko, he works at Epic. I work with him at another studio in Germany. Him and I were looking at a game, and he introduced me to these 40 style kind of pastel vacation posters, and I really like just the color and kind of the look and the contrast and everything that it has here. And I feel like, while this doesn't necessarily show anything about carnival games, but what I do like here is the colors that are being used. So if we injected some of this color use into the carnival game, I think that would be interesting, and that's what this is meant to show off. These don't have to be images of something that's in the real world. They could be abstract images, just as long as you can get the point across. Using this is to what you want to do. So yeah, we got some more for the ring toss here, our shooting gallery. This is kind of modern minimalistic style. I've got a combination of Portal, some architectural viz rendering, and Wall-E here. You know, because I like the simplistic environments they had in Wall-E. Especially the contrast between the crazy dirty earth and the very slick and smooth ship. I really like that slick smoothness that the ship had. It just felt cool. It just felt cool. So I thought, you know, injecting something like that. But say Wes had never seen Wall-E before. He'd never played Portal.
You could try to describe that.
I could, and I could be like, well, there's these gooby things that come out that look like meta balls, and Wes can be like, what is he talking about? But
I say that anyway sometimes.
but now I just show him. I'm like, I want something that looks like this. And he's like, oh, okay. I completely understand now. Ski ball. Let's see. Strongman. Whack-a-mole. And we're back to the beginning. Now, you notice that we don't have a lot of these games already there. I just went out and started researching carnival games. You know, and I spent some time putting all this stuff together. So you know what? If we do decide to add Whack-a-mole in, this is already done, right? This is... Yeah, he's hiding. It was actually hard to find a picture of the Whack-a-mole mole. Trying to find a picture of the Whack-a-mole mole was really hard, actually. So
I really want to do this multiplayer. Look at that one right there, the duel.
Yeah,
That
that'd be awesome. So let me come back over here to my notes really quick, because there's a couple other things that I wanted to talk about. So yeah, I gathered I'm at, I think I made a new one today as well. Oh yeah, it was the carnival ones, the carnival games. This was a new one that I made this morning. I still need to make some more for the tents, just to get like, you know, how I want the awnings to look, or do I want to use, you know, PVC to put them together, what I want the connectors to look like, and things of that nature. And this just makes it easier for me to send somebody one mood board with something instead of like a collection of images, or because maybe I put the wrong images in the folder, maybe I sent them the wrong folder. It's not to say that you couldn't screw up the mood board, but it's a little not as easy to do.
No, they're great. I mean, it really helps you kind of get the vision and nail the vision down once you have, you know, some ideas, some things to look at.
Yeah. So the next thing I want to talk about is team considerations. Now, luckily, Wes and I get to sit next to one another, so it was pretty easy for us to come up with a team. And we've got Perforce, and we've got Dropbox, we've got all these things. We've got the Q Drive where we can share projects with one another. So it's very easy for us as a team. But when you're building a team, some things to think about is the size of your team, right? You could have a team that consists of 2 people, and then you go out and you get contractors to do whatever it is that you need to do. And then you bring their work and you bring it back into your project. Just because you need something done on your team doesn't mean you necessarily need to bring in a whole other team member and open up your entire project to them. You know, getting people on forums to do a very specific part, that also helps you make sure that you actually need this specific part done. Because if you bring in a contractor, you have to give them, you know, here's what I need you to do. That forces you to really type everything out, really think hard about what it is that you're working on, what it is that you need from this person to do. I would also, one of the things I've started is a very, very simple Excel spreadsheet, Google spreadsheet, I'm sorry. And it's just like, it says the name of the asset, has it have a mood board? Does it have a white box? Low, high poly, textured, final asset? And I just put an X in each one of those. I'll make one for each asset in the game, just add it as a new column. And that way we can really very, very simply track what's going on, what the progress is of anything in the project. And with 2 people, that's not super important.
It's a good habit, though. It's a good,
but life happens.
That,
and say both of you have to put the project down for 6 months because life. And then you come back and you're like, where am I? What was I doing? I have no idea. Having a tracking sheet like that can help you get back into the swing of things a little easier. Let's see, art pipeline considerations. So for this stuff, I've been using a combination of 3D Max, Substance Painter, and Substance Designer, and Mudbox because they have a really, really great Baker and Mudbox. And that's just for me. Those are the programs that I have access to. But for you, you could do something like Blender or Substance or GIMP or Photoshop. But whatever it is that you happen to pick for your software, make sure that the people on your team know which software, but more importantly, if you're using a specific plugin, like the NVIDIA normal map filter plugin, like that's how we're going to generate our normal maps, or we're all using Crazy Bump or something like that. Having people be fully aware of the software you're using can help eliminate a lot of those, like, I have no idea why this looks different when I brought it into the game. I don't know.
Essentially, even version control of that software too.
Yes,
different versions.
And speaking of version control, let's talk about version control. For us, we are building it out of our Google Drive. We zip up builds, we put them in there. It's giving us a little bit of problems because of the intermediate folder.
We should move it to Perforce.
Yeah, we're gonna move it. Eventually, we'll move it to Perforce. But at this stage, we're kind of working independently of one another. But when you're working on a project, picking something like Perforce or Subversion or Alien Brain or something like that. Perforce, I do believe, is free for up to 5 licenses. Like 5 individuals can use your Perforce depot. Perforce, the only reason I say Perforce is the only one I actually have a lot of experience using. The other ones, like Alien Brain, is supposed to be very good. Subversion is supposed to be very good. But pick something and make sure you stick with it. Make sure people are checking things in, checking things out. Not everybody on the team has to have access to it. You could do like what we're doing and say, you know what, guys, here is the latest and greatest build that I want you working out of, and you put that into a zip file on your Dropbox somewhere. They pull that down, and then they're submitting files back up through zips or something like that, and you are actually physically taking that and putting it inside of the master Perforce project. You know, because there's not a reason that everybody needs Perforce access. I mean, unless you're in like a central location, like a studio or something like that. Here's another interesting thing. What kind of naming convention are you going to use? Unreal has a lot of great tools for making collections and things like that. But if you were going to make like this mouse right here, you know, if I just call this like Sam's Awesome Mesh, and then it's texture 1, normal, roughness, you know, when I go look, I'm like, what is this roughness texture? Now, luckily, Unreal has a lot of ways where you can backtrack and figure out where something goes to. But being able to say, you know what, this is called SM mouse _00, and it's T mouse ALB for albedo 00, T _ mouse N for normal 00. Having something like that makes it a lot easier if you have to search through your source control, or if you're trying to figure out, or you need to give something to a programmer, and he's like, I need what's the name of this static mesh? Well, you know it's SM static mesh. SM mouse 01, right? Just having a naming convention that you stick to within your project just makes things so much easier to do, because you're never once like, ooh, where does this go? What does this belong to? Can I delete this? Can I get rid of this? Do I need it? And then you delete it, and you're like, oh, I didn't have this level loaded. And all the textures are broken because you deleted this one thing because it was just like Sam's Awesome Texture 2. And you're like, what is this, a testing texture? I don't know. Let's see what else. Another thing you can talk about, if you know you're doing this and you're on a shoestring budget, you're like, look, I don't have the software to give to people and things like that, then pick a file format and have people deliver stuff in that. I want all of my objects LOD'd, or all of my meshes to come in the FBX format. Can't give me anything else. I need FBX. I want all my textures to be PNGs or Targas or something like that. But make sure you pick a format and you stay consistent. And let me see what else we got here. So, and next thing I want to talk about, I'm just going to talk about this briefly because it is something you need to consider, but performance and optimization right from the get-go. For this game, I have been making sure that all of my meshes stay around or below 5,000 or 6,000 triangles. The basketball goal goes a little bit higher than that. I just need to remove a few edge loops, and I'll be back to where that is. Now, that's a completely arbitrary number. I just was like, you know what?
You could have a baseline there to kind of shoot for, rather than being all over the place.
Yeah. Rather than having something that's like 1,000 triangles and then having something else that's 10,000 triangles, I'm like, okay, if it has to go over 5, it's okay. If it's got to go, like basically 10 is my hard limit. I'm not having anything that's over 10,000 triangles. If it does, I'm going to split the mesh up into 2 separate meshes. But now that I know that I have some type of number to work with, I can then start pulling things back or pushing things up. and how to find a real baseline of that is, honestly, you take your white box mesh, you make it about 2 to 3 times the vertices that it needs to be. So if you're making a basketball goal, I'd make it 5,000 or 6,000 K, you know, just the white box, and you just add a bunch of extra edge loops on there so you get something around there. Then you start placing it around the level. Then using the built-in performance tools, you measure your performance. You see how many polys you're pushing each frame. Yeah. And that way you can get a better idea of, you know what, this basketball goal, he can only be 2,000 triangles when he's all said and done, because having 3 of them, it's way too much. Yeah, it just blows performance out. So one of the other things, and this is super key for VR, is LODs. Now, LODs are not going to increase, they're not going to affect your performance, but what they are going to do is they're going to increase your install size negligibly, but it is still going to be a size. They're also going to increase your memory, your running memory size. Okay, again, this is negligible, but it is something you need to consider. And for the basketball hoop, for example, I have 3 LODs. I have the main one, or I'm sorry, 2 LODs. The main one, then I have LOD 1, which I remove, like basketball hoops, they have little hooks down here for the net. I remove all of those. I remove every other every other triangle line, and the net itself, and then in the little connecting beams that hold it up. And then for the last LOD, it's like a 5-sided tube for the rim and things like that. But again, it's only going to be like that big on the screen, so you're never going to see it. You just need to have a good silhouette. There might be something else where I need 5 LODs. There might be something where I only need 2 LODs. But the key importance here is that I'm going to have LODs for everything. And a good rule of thumb is that your first LOD should be at least 50% less than your main mesh. So if you have 10 LODs, but each one is only taking out 1,000 triangles, you might want to reconsider and go more aggressive on that one. Here's a good one. How are you going to set up your UVs? Are you going to use tiling UVs, which means they go out of the 0 to 1 UV space? Because I'm going to be giving a lot of stuff to Wes where he can kind of build stuff modularly and then use the merge actor tool. I want everything that we make to be in the 0 to 1 UV space. It doesn't need to be uniquely unwrapped, such as a light map, but you can still have UV islands that stack on top of one another. But the reason I want to do this is because the merge actor tool literally will take all of these actors, merge them together, and then puts its UVs like this. And if I have something going out of the 0 to 1 space, it's going to get cut off, and it's going to look really crappy. And when he's going to merge it and be like, dude, this looks horrible. What'd you do? This is garbage. So, and again, since it's a VR game, everything's going to have a second light map because we need that sweet, sweet performance back. So we talked about triangle counts, and this is not really something that is a one-fits-all solution. I can't just say, you need to have X amount of triangles, and that's it, you'll be good. Every project is different. Every single project is different, even projects going from like the 360 to the PS3 or the PS4 or the Xbox One. You might be able to push more on one than the other one. So let's see. So that is it for me. The last question we've got is, can they show how to use the switches and the materials? I think we still have the editor open, so I can show how to do this really quick. It's ridiculously simple. So let's go to this guy. So basically, I'm going to disable this switch. Voila. That's it. Now I can change the color of this guy. We'll have a nice red can here. And if see, now the cans are red. Oh, I know why they're black. No reflection capture actor. Oh. Because it's metal. Yeah. Duh, that makes total sense. So, and if I wanted to, I actually want that back. I just turn that back on like that. It's that simple. Now I'll show you how to set it up inside of the material itself. It's ridiculously easy. I say that it's going to take a little bit of trial and error if you've never done this before to get it to work right. But basically, that's down here. No, that's the static one, and I want the switch.
Static switch parameter.
Where is that? Oh, static switch. Yes, here, the static switch parameter. So basically, I'll pull this up here. And we will, just for the time being, we're going to plop down. Do this, do this, and we will set this guy to green, and we will set this guy to red, and then let's see, let's enable real-time preview. Oops, no, I want to, can I not preview this node?
Live nodes.
Let's just do this. Okay, so I don't think I can preview this because it's literally telling it to go to this one or this one, but I can preview the multiplying that's going. Yeah, it's basically no output. So this one, the default value, it's going to be false. So it is giving me green. If I just put on this boolean, it'll say the default value is to true, which is the red. Okay, and then that's this right here, this little flag that I'm switching on and off is literally what this little flag is doing right up here. It's switching it on and off.
Actually, never used that. That's pretty handy.
So they're very handy. Now there are some caveats to using this. Each time, if I went through this material and I couldn't make up my mind of what I was doing, and I just started turning things on and off and back on and back off, I'm going to generate a lot of permutations of this shader. That's the one kind of gotcha with this one. It's very powerful, but it can quickly blow out your shader cache if you start just, I don't know what this stuff does, so I'm just going to start pressing buttons and see what happens. It's not like, oh my god, my game is never going to run. It's just, no, your shader cache could be maybe 2 or 3 times the size that it would normally be because someone has made a lot of permutations of the shader. But this is, I mean, this is a really, 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 really awesome feature to have right here, because you can literally take a shader and say, you know what, this is way too expensive. Boop. I have just literally killed half the instructions on this. So let me check back here and see if we've got anything else. Nope. So we talked, let's go back up to the top of the list here in my speaking notes. So we talked about coming up with an art style, talked about team considerations, pipeline considerations for your art, naming convention, performance and optimization. Yep, that's it. That's it for me. That's everything that I wanted to do. It's 3:04, so it looks like we're doing pretty good so far.
Anything else, really?
So if nobody's got any more questions for us, we will be back in the new year. Hopefully we'll have a little bit more time to work on this project. I know I'll be working on it this Friday for our Epic Friday. Okay. All right, well, that's all for me. If you guys got any questions or there's something you want us to cover more in detail, please post to the forums. And we will see you next time. Thanks for tuning in.
Thank you, guys.
See ya.